The next particle nature is photoelectric effect. This is very important concept, problems point of view. Students, problems point of view, this is very important. Photoelectric effect. Simply, what is the photoelectric effect actually? The photoelectric effect is nothing but ionization energy definition only. Nothing is there in that ionization energy definition. You know that already, ionization energy definition. What is ionization energy? The ionization energy definition is the amount of energy is required removal of electron from its neutral gaseous atom. This energy is nothing but here h nu. H nu is nothing but light, in the form of light. Light having energy. Na? So photoelectric concept is based on the ionization energy definition simply. So what is the photoelectric effect observed here? This is the metal. Inside the metal, so many metallic atoms are present. So metallic atoms, this here the positive charges indicates the nucleus, and a valency electron is present. These are the valency electrons. I am represented on the surface of the metal, that valency electron. So I want to remove that valency electron. That is nothing but from the valency shell, the electron is removing simply by using the energy. That is which energy? Incident light energy. So certain frequency of incident light strikes on the metal surface. Certain frequency of incident light, frequency in the form of energy. Frequency and the energy relation here, E is equal to h nu. We know that already in the black body radiation. So certain frequency of light strikes on the metal surface. That energy of incident light convert here two parts, utilizes as a two parts. One part is, it is break the interaction between nucleus and the valency electron. Here the interactions are present, that interactions is breaks by incident light, some amount of energy. Between nucleus and valency electron interactions are present, that interactions is nothing but threshold energy. The threshold energy W naught is equal to 5, that is nothing but h nu naught. So threshold energy is the metal related energy. So this incident light break the interactions between nucleus and valency electron. Now after breaking that interaction, remaining amount of energy is converting to the kinetic energy to that electron. So ejection of electron takes place. That is called as photoelectric effect. So simply, incident light, certain frequency observed here, certain frequency of light strikes on the metal surface, ejection of electron takes place. That formula is E is equal to W naught. That means this amount of energy is converting into two parts, threshold energy and kinetic energy of the electron. E is equal to W naught plus kinetic energy. E is nothing but h nu, and h nu naught and kinetic energy. Kinetic energy, you know that, half mv square. This is the photoelectric effect. But how it is related with particle nature? Metals, you know that metals, different metals are there. Every metal have same size? No, different size. Every metal have same kind of threshold energy between nucleus and valence electron? No, different sizes, different threshold frequency values are there. So that the different threshold frequency values, different threshold energy values, due to that different energy light is absorbing. In the white light, for suppose, different lights are, different colors are there. Every color have a different energy. So every metal have a different threshold frequency, absorbs a particular frequency of the light from the white light. So all the colors have same energy? No, different energies. So particular metal absorbs different energy. So absorbing is continuously going on, discontinuously going on, discontinuously is going on. White light, from the white light, all the 7 colors are not absorbing. Particular color is absorbing. That indicates that light travels in the form of particle. Remember this. Particle. Different metals absorbs different frequency of light. So here the note. Incident light energy, that means frequency, is more compared to threshold frequency, then only photoelectric effect is possible. Here the threshold energy is dominating compared to incident light. That incident light is possible to break the interaction between nucleus and electron? No. Photoelectric effect is not possible. Incident light energy is more compared to threshold energy, then only photoelectric effect is possible. So that means incident light frequency is more compared to threshold frequency, photoelectric effect is possible. This point in terms of wavelength, nu is equal to c by lambda. So the relation is inversely proportional. So incident light wavelength is less compared to threshold wavelength, photoelectric effect is possible. This is important relation, students, in terms of frequency and in terms of wavelength. Now observe here. Every metal absorbs particular frequency, then photoelectric effect takes place. I gave you that point already. Particular metal absorbs particular frequency of light. That is the meaning of the particle nature of the light. So observe the graph here. Graph h nu is equal to h nu naught plus kinetic energy. H nu is equal to h nu naught plus kinetic energy. The graph is related with the kinetic energy of the electron and frequency of the light. Kinetic energy of the electron and frequency of the light. The graph. So K is equal to, I am writing this above equation, K is equal to h nu minus h nu naught. So Y is equal to mx minus c. This is look like the formula Y is equal to mx minus c. So on the x-axis frequency, on the y-axis kinetic energy. So here this is the intercept. This is x, this is y, this is intercept. So based on this graph, frequency increases, kinetic energy of the photoelectron increases. So this graph also important, students. So, and one more important point here, different metals. For example, here sodium, potassium, magnesium, copper is present, which is readily involved in the photoelectric effect. How it is possible to identify which metal is readily involving. So note, observe here, what is the ionization energy definition? The amount of energy is required for removal of valence electron. What is photoelectric effect? Frequency of light. Certain frequency of light strikes on the metal surface, ejection of electron takes place. Which metal is readily lose the electron? That metal is readily involving in the photoelectric effect. Which metals are large size in the periodic table? S block elements. S block elements are large size compared to D block element. Copper is the D block element. These are the S block elements. This is second A group element. These two are first A group elements. First A group elements are larger in size compared to second A group element. Sodium and potassium comparison, potassium is the large size, that is readily lose the electron. So readily involving in the photoelectric effect. So in terms of work function value increases, photoelectric effect decreases. Work function value of the D block elements is more compared to the S block elements. So this is the photoelectric effect. Photoelectric effect and black body radiation tells that light travels in the form of particle packets of energy, that is photon, that is nothing but quantum. This is the particle nature of the light. Now going to the postulates.